Hey guys, welcome back to my channel. In this video, I'm going to be continuing the series where I do IB Chemistry HL Paper 1 questions on camera with you guys. In this series, I go over multiple choice questions and pick an answer, but in the meantime, I actually explain my thought process so that you guys can understand it too. Given the support that I've received from my previous videos, I decided to continue this series. Before we begin, I'd like to remind you that this channel is quite small and any help that you any help or support that you provide, whether it's a subscription, a comment, or a like, is highly appreciated, and it is completely free for you guys, but it means so much to me. So if you guys do enjoy my content and find it helpful in your revision for your exams, please don't forget to click the thumbs up button. And without further ado, let's get right into the video. Which volume in cubic centimeters of 0.2 molar sodium hydroxide is needed to neutralize 0.05 moles of hydrogen sulfide? So hydrogen sulfide to sodium hydroxide is in a 1 to 2 ratio. First, let's calculate the number of moles of hydrogen sulfide that's used. So if there's 0.05 moles of hydrogen sulfide used, then we need 2 times as much sodium hydroxide, which means we need 0.1 moles of sodium hydroxide. To get 0.1 moles of sodium hydroxide from a 0.2 molar solution, we need half a cubic decimeter, half a cubic decimeter of liquid. But the answer is required to be in cubic centimeters, so we're going to convert that to cubic centimeters, which is just times 5,000. You get 500 as our final answer. The complete combustion of 15 cubic centimeters of gaseous hydrocarbon X produces 60 cubic centimeters of carbon dioxide gas and 75 cubic centimeters of water vapor. What is the molecular formula X? All volumes are measured at the same temperature and pressure. So if it is the same temperature and pressure, we can assume that the volume is directly proportional to the actual number of moles. So if we say this is hydrocarbon X, and let's say that 15 cubic centimeters is 1 mole, then 60 carbon dioxide gas would mean there's 4 times as that. So there's a 1 to 4 ratio between the hydrocarbon and carbon dioxide. And with water vapor, there's a 1 to 5 ratio because 15 times 5 is 75. So it looks to me like there's 4 times carbon, and looks to me like there's 5 times 2H. So it looks like there's 10H and 4 carbon. So therefore, this compound is going to be C. Notice it is the molecular formula, not the empirical formula, so we don't have to have the lowest common ratio or lowest common ratio of atoms. 5 moles of iron oxide, this should be iron 3 oxide, and 6 moles of carbon monoxide are reacted according to the equation below. What is the limiting reactant, and how many moles of excess reactant remain unreacted? So 5 moles of this to 6 moles of this. So for each 1 mole of this, we need 3 moles of this. So it looks for 5 moles of iron 3 oxide, we would actually need 15 moles of carbon monoxide. But since we don't have that much, we don't have enough carbon monoxide, we can deduce that this is the limiting reactant. We don't have enough of it to fully react with the iron 3 oxide. So we can eliminate options C and D. The moles of the excess reactant remaining, well, if this is the limiting reactant, that means all of it will react. And if all of it reacts, then if 6 moles of carbon monoxide react, we have 1/3 of that amount in moles of iron 3 oxide reacting. So 1/3 of 6 moles is going to be 2 moles. So 2 moles of iron 3 oxide is going to remain. It's going to react. And we have 5 moles initially, so 5 minus 2 will be 3 moles that remain. So the answer is going to be B. What is the correct line for the emission spectrum for hydrogen? Line M has a greater energy. What is correct for the line emission spectrum for hydrogen? Let's see. So we have line M, line N, line O, P, Q, R. It looks like this is higher energy because lines of emission converge at higher energy, and this is lower energy. This is lower energy. Line M has a higher energy than N. That seems to be correct. Let's just compare the other ones. Line N has a lower frequency than line M. Wait, sorry, this is not correct. So N has a higher energy than M. N has a lower frequency than M. Well, it looks to me that N is of a higher energy than M, so its frequency also should generally be higher. Line M has a longer wavelength than M. M seems to be lower in energy. M is lower in energy than N. And if we know one thing, it's that energy is to inversely proportional to wavelength. Wavelength is lambda, right? Yeah, so that means that a higher wavelength means lower energy, and a lower wavelength means higher energy. So the lower energy here would mean there's a higher wavelength in M than N. So C would be our answer. And also D literally does not make sense because the lines we know by definition converge at higher energy. Which representation would be correct for species Z, which has 31 protons, 40 neutrons, and 28 electrons? Well, if we have 31 protons and 28 electrons, we're going to have a +3 charge, so we can eliminate this option immediately. The total number of nucleons, or the atomic mass, would be 31 plus 40, so 71. These seem to be correct, and the number of protons would also be 31, so this number on the bottom needs to be 31. And we've already eliminated this option, so A is our only correct answer. A period 3 element M forms an oxide M2O, which represents the first 4 successive ionization energies of M. So if it's M2O, that means M has an oxidation state of +1, because we need +2 to cancel out the -2 of oxygen, to -2 oxidation state of oxygen. So that means it would have a relatively small first ionization energy because it can form this 1 plus ion, but afterwards there'll be a huge jump from the first to the second, and from then on it's sort of irrelevant. So if we look, only option A has a large jump. This one's just doubled, this one's sort of like tripled, this one's also like doubled, so these are not large enough, whereas this one is almost a times 10 increase. Times 10 increase in ionization energy, so A is our correct option, correct answer. Which property increases down group 17? The halogens. When we go down group 17, what happens? The atomic mass increases, so the number of electrons increases, and with the number of electrons, we have stronger London dispersion forces. So stronger London dispersion forces would mean stronger intermolecular forces, and these need to be overcome when boiled. So the boiling point, there will be more energy that's required for boiling to occur, and so there'll be a higher boiling point when you compare halogens at the top of group 17 to those on the bottom, which correctly describes the reaction between potassium and excess water. When potassium is reacted with water, I'm pretty sure it forms potassium hydroxide, not potassium oxide. The final pH would not be 7 because it would be basic, because potassium hydroxide is basic. It would not be endothermic because this reaction generally has explosive properties, because potassium is an alkali metal, and when you put it in water, it generally reacts really fast. So C seems to be the correct answer. The oxidation state of cobalt in complex ion, yes, is 3. Which of the following statements is true? Okay, so this is 3 plus, Br is going to be minus, and NH3 is neutral. So the overall charge is going to be +2, that's correct. Complex ion is octahedral. Let's see, so we have 6 different ligands, so that's correct. The cobalt 3 ion has a half-filled D sublevel. I believe that cobalt actually has 6 electrons out of 10. electrons at its d sublevel, so this statement's wrong when it forms an ionized compound. Sorry, when it forms a cation, so it forms the 3 plus ion, so it's going to be 1 and 2, so it's A. Therefore, A is our correct answer. What is the correct explanation for the color of copper hexahydro? I don't even know what that's called. So the copper is 2 plus, and when we talk about the color of complex ions, it's always about absorbed light, so we can eliminate these. Sorry, we cannot eliminate this one. We can eliminate this one, and when light is absorbed, electrons move to a high energy, so this option, and it's all in the d orbital, so this one's incorrect. So it's from the ligands. No, that's wrong as well. So A is the correct answer. What happens is when a ligand forms a coordinate bond with the central metal ion, we actually have the d sublevel splitting into two. It's like so the d sublevel is originally 5, but what happens is 2 of them go up, 3 of them stay down, and the electrons can absorb light energy, and one of the electrons can get promoted. And when this happens, certain wavelength of light is absorbed, and when light is absorbed, it's basically absent from you to be able to see. So you see the complementary wavelength of light. So A is correct. If you guys would like a deeper explanation of crystal field theory and how color works in these complex metals, please leave a comment down below and I'll be happy to get to that soon. But in the meantime, let's go over to the next question. How many electrons from the carbon-oxygen bond? How many electrons form the carbon-oxygen bond in methanol? So methanol is an aldehyde, so it should be 4 electrons because carbon is bonded to 2. Carbon forms a double bond with oxygen. Be careful because this question might trick you into thinking that methanol is like that, but that's actually methanol, not methanol. Alright, so this one's wrong. Between which paramolecules can hydrogen bonding occur? CH4, nope. Nope, this can't happen. There's here it looks to me that there is an alcohol, sorry, hydroxide a bit, so there's a carbon hydrogen bond, so there is hydrogen bonding, there's hydrogen bonding here, it's water, so D is our correct answer. Which substance has a giant covalent structure? Well, giant covalent structures, one of the properties is a high melting point, so these are eliminated. Giant covalent structures have no solubility in water. Electrical conductivity in molten state, there should be no conductivity at all. Oh wait, yeah, there should be no conductivity at all in the electrical, even in the molten state, so D is our correct answer. Which species has bond angles of 90 degrees? Okay, this is a bit tricky. First, we'll have to draw out all these structures. So this is probably one of the most time-consuming questions on an exam paper. So let's draw out aluminium tetrachloride, or whatever it's called. So first we need to find the V, the number of electrons in each of these. So the more specifically, the valence electron. So aluminium has 3, and we have 4 times chlorine, which has 7, plus we have a negative charge, so we add that. So it looks like we have 28 plus 4, which is 32. For this one, we have 7 plus 7 times 4 plus 1, which is 28 plus 8, so 36. For this one, we have 5 plus 4 plus minus 1, which is going to be 8. For this one, we have 4 plus 28, which is 32. You guys should be able to follow along. And let's try and draw the structure. Actually, it's kind of awesome like this, I believe. Actually, let's not focus on that for yet. Yeah, let's not work on the stereochemistry yet. Now let's see, if we fill this up like this, we have 4, 4, 4, 4. So we have what do we have? 16 times 2, electrons. So because each of these may represent an electron pair, so we have the 32 electrons. So this seems to be correct. And because of that, we know this is tetrahedral electron geometry, and the molecular geometry would also be tetrahedral because we have no non-bonding electron pairs. And because of this, we don't have any lone pairs. And in the tetrahedral molecular configuration, I believe that all of them are 107 degrees, something like that. So it's not going to be it's not going to be the answer with a bond angle of 90 degrees. Now let's try out the next option, which is iodine. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Now this one we have 32 electrons again, but we need 2 more, so we got that. This looks to be like a 6 electron domain structure, so this is going to be octahedral. And here we have 2 lone pairs, so we're going to have a square planar structure. I believe it's square planar structure. If we have a square planar structure, that means the bond angles are 90 degrees, so it's going to be B, which is our answer. In this question, if you have time realistically, which you will for paper 1, you're gonna most likely check answer option C and D, but I'm gonna assume that we don't have enough time, so I'm gonna just confirm my answer as B and move on to the next question. What is the hybridization of the numbered atoms in the ethanoic acid? So here we have carbon bonded to 4 things, so that's sp3. We can eliminate that option. Yep. And we have carbon atom 2 bonded to 3 things, so that's sp2. We can eliminate that there. And oxygen 3. This is quite tricky. You might think that's bonded to 1, 2 things, but that's wrong. It's actually got 2 lone pairs as well because it's oxygen. So this is also tetrahedral, so it's going to be sp3 hybridized. So the answer is going to be D. sp3, sp2, sp3. Hydrazine reacts with oxygen. Okay, that's hydrazine apparently. So it forms nitrogen and water. What is the standard enthalpy of formation of this thing in kilojoules? The standard enthalpy of formation of water is that. Well, the standard enthalpy of formation should be based on the elements. So the elements, component, elements in standard state. Component elements in standard state. So because we have hydrazine having this and this, we're basically gonna have to reverse this reaction. So the enthalpy change will be with nitrogen gas, and that's gonna be negative 623. But we're gonna have to reverse that sign because we're going in the opposite direction. So it's gonna be positive 623. So it's gonna be one of these bottom 2 options, and because we have water being 286 and we have 2 of those, it's going to be something with 572. So not going to be this option, it's going to be C most likely. So for this question, it shows that I don't really have that good of an understanding of what standard enthalpy of formation is and how to calculate in this circumstance. But given what I know, I can eliminate the options so that I have the correct answer in the end without even having to know the content really well. So it's about manipulating what you have in front of you, not really knowing the content itself, which is a very helpful technique for when you're stuck in a paper 1 or paper 2 or any paper question. 5.35 grams of solid ammonium chloride was added to water to form 25 gram solution. The maximum decrease in temperature was 14 Kelvin. What is the enthalpy change for this reaction? Mole mass is that. Specific heat capacity. Okay, so delta H equals negative Q over N. So the reason I looked at Q is because there's a temperature change given, so I'm going to have to use Q equals MC delta T. And because 4.18 is the joules per gram per Kelvin, I'm gonna have that as my C value, and I'm gonna have to multiply mass is 25, so it's gonna be 25.0 times 4.18 times 14 divided by 1000, because we have to find the kilojoules. So, and then we have to divide by the moles, which is going to be mass over molar mass, which is 5.35 over 533.5, which is 0.1. So the answer is going to be this one. Well, it's going to be a positive value for the heat change, right? But then overall it's going to be a negative value because we put the negative up front. So it's not this, not this. It's going to be this. Oh, wait, I'm forgetting something. This 14 is a fall in temperature, so it's actually negative. So I nearly tripped up on that. I probably would have in the actual exam because I just thought this was probably, yeah. Okay, so if this would have been a negative, the negative up front would have cancelled with this and left a positive. So it's either one of these ones. And from the looks of it, this one doesn't have a divide by 0.1. So this one's eliminated, this one's eliminated. This is the correct answer, which represents the enthalpy change of hydration for chloride ion. Enthalpy change of hydration is when you go from a gaseous, I believe it's a gaseous ion, and you go to an aqueous ion. So it looks to me like A is the correct answer. Which ionic compound has the largest value of lattice enthalpy? Lattice enthalpy is going to be higher if we have a stronger ionic compound, so that'll be a really strong high charge compound. So if we look at these questions here, if we have a really high charge separation, so let's look at the cation first. It's not going to be sodium because that's +1, whereas all these other ones are going to be +2, so it's going to be a stronger, higher charge density. It's not going to be Br2 because Br2 is consists of bromide ions, which are all -1, whereas oxygen and sulfur are -2, which is going to be something of greater charge density. Next, we're going to consider how strong these are compared to each other. So, sulfur, I know when it comes to being negative, it has a lower electronegativity than oxygen. So, oxygen having the high electronegativity, and the anion in these compounds having the high electronegativity means that the E-neg difference is going to be higher for this one than this one. So overall, this one is going to be the stronger compound. So because it's a stronger compound, when we split the lattice, this one's going to require more energy, so B is the correct answer. Which experimental methods could be used to observe the progress of the following reaction? Changing color, we do have chromium ions, and they are changing in oxidation state, so this works. Change in mass, we don't have a gas being produced at all, so this doesn't work. Change in electrical conductivity, the number of ions goes from 721 to something much less, so this does work. So 1 and 3 seem to be the correct answers, so B is the correct answer. Which statement describes the characteristics of a transition state relative to the potential energy of the reactants and products? Transition states are never stable, and they're unstable, and they have high potential energy because they cannot be maintained and they will react to form a product. The decomposition of hydrogen peroxide in an aqueous solution proceeds as follows. Okay, the rate expression for the reaction was found to be okay. Which graph is consistent with the rate of expression? We have a first order reaction, so the rate as this one increases, this here we see that it increases more than linearly, so this is a second order reaction, that's incorrect. This is a zero order reaction, that's incorrect. This is um, this is a zero order reaction as well, that's incorrect, so D is going to be the correct answer. This is a zero order reaction because across time the rate of decrease of hydrogen peroxide is actually constant, so it's unaffected by the hydrogen peroxide concentration, so the rate would be, this is basically the same graph as this one. The rate constant K is commonly described in the Arrhenius equation. Which of the following statements are correct? The greater the activation energy value results, it will result in a smaller K value. Let's see. So if we have a higher activation energy since it is a negative value, yeah, I believe that is correct, right? Because if this EA value becomes higher, then the overall E value becomes smaller because you have a higher negative number, the power of E, and so you'd get a smaller K value overall. That's correct. Reaction of less complex molecules usually have a greater value of A. I believe the Arrhenius equation, the A value is to do with the rate of collisions being successful, having the right geometry and some of that stuff. So I believe that this would be correct because the less complex ones would have an easier time. So this is to do with the frequency of successful collisions based on geometry and activation energy. So if there are less complex molecules involved, they would have a lower value of A. So sorry, they would have a greater value of A because the frequency would be greater. The slope of the gradient of ln k versus 1 on t equals EA. That's true because we work out EA from that gradient right there. But just to be, yeah, so it looks like all three options are correct. So let's go with D as the answer to this question. What happens when temperature of the following equilibrium system is increased? It looks to me like it's an exothermic reaction, so we could describe heat as literally being a product. Temperature is increased, meaning we increase the product, so we shift to the left. So this is done, and reaction rate at the forward and reverse reactions would increase because we have an increase in temperature. Increase in temperature results in greater collision frequency and greater successful collisions, greater activation, ability to overcome activation energy. So energy greater than activation energy is more likely. A mixture of 0.4 moles of carbon monoxide and 0.4 moles of hydrogen gas was placed in a 1 cubic decimeter vessel. The following equilibrium was established. At equilibrium, the mixture contains 0.25 moles of carbon monoxide. How many moles of hydrogen gas and that thing? I think that's methanol. Methanol um, were present in equilibrium. So for this question, you could use a rice table, but I'm just going to compare the change from here to here. There was a 0.15 molar decrease, so 0.15 moles of CO2 reacted. That means double the amount of hydrogen gas would have reacted, so 0.3 moles of hydrogen gas would have reacted to give us 0.1 moles remaining. And so this seems like D is the only answer anyways. But let's just work out the methanol concentration. So if we have 0.1 moles of CO forming carbon monoxide reacting, then we would have 0.15 moles of this thing being produced based on the stoichiometric coefficients. And it seems to me that this works. So D is definitely the correct answer. Which species behave as Bronson-Lowry bases in the following reaction? Bronson-Lowry bases are proton acceptors. So if we look at this is an equilibrium reaction. So we have this happening and this way happening. So let's put this and this. So we have this thing to this thing. So we have this nitric acid accepting a proton. So we have nitric acid acting as a Bronson-Lowry base. And on this side we have hydrogen sulfate gaining one more proton or one more H to become sulfuric acid. So hydrogen sulfate looks like the other answer. So A seems to be the correct answer. What occurs when solid sodium hydrogen carbonate reacts with aqueous sulfuric acid? Okay, so if we have sodium hydrogen, what even is that? Oh, sodium hydrogen carbonate. There we go. NaHCO3 reacts with aqueous sulfuric acid. Well, if we have this reaction occurring, we should have something like sodium sulfate forming, I believe. But since we have a metal carbonate reacting with with an acid, we should have carbon dioxide form. So it's one of these two. And I think that because we have a H2 here and this molecule forms water, I believe it forms water. I'm not sure about hydrogen. I don't think it forms hydrogen. So I'm not gonna say it forms hydrogen. So I'm gonna eliminate option B. I'm gonna go with option D for this question, but this might be wrong. I just from my knowledge, I don't think hydrogen's formed in this reaction. I believe that hydrogen is formed when you have a reactive metal reacting with an acid. Which mixture is a buffer solution? For a buffer to exist, we need partial neutralization of a weak acid or base with a strong substance, like strong complementary substance. So if we have an acid, we need a base. If we have a base, we need an acid. So first of all, let's identify the weak and strong components. Let's eliminate option C and D because we have a strong strong base and a strong acid, and those cannot form buffers at all. Here we have a weak base, ammonia, and a strong acid, hydrochloric acid, and we need to have more of these. Since we have the same concentrations of the two, it's going to be the volume that determines whether partial neutralization occurs. For partial neutralization to occur to form a buffer, we need the weak component to be in excess, which we have in option B, because we have 50 cubic centimeters of 0.1 molar ammonium ammonia aqueous solution, whereas we only have 25 cubic centimeters of 0.1 molar hydrochloric acid. So this is going to partially neutralize the ammonia, and we're going to have a buffer system in place, whereas this one's going to fully neutralize. So A is incorrect. Buffers are really tricky, and it's quite hard to get a good grip on this. So if you guys want to see a future video on buffers, please write that in the comments down below, and that'll be a good reminder for me to make a video on this topic in the future. Which salt solution has the highest pH? If we're looking at highest pH, we're going to have a basic solution. That means the conjugate base of something is strong. So strong basic component. So a strong base component comes from a weak acid. So a weak acid. Here it looks like the ammonium part from a weak base. So this is strong acid part, so this is not going to be it. We have carbonate, carbonic acid, sulfuric acid is strong, so that's not going to be it. Nitrate's not going to be it, so because nitric acid is really strong, so the only other option is this carbonate one, so I believe that C is the correct answer. I'm not sure, but let's just go with C because you got to think about the conjugate. So the conjugate of a weak acid will be the anion component. So the chloride, which is going to be a weak base because the chloride comes from a strong acid generally, like hydrochloric acid. The nitrate ion again, it comes from a strong acid, nitric acid. The sulfate ion again, strong acid. Whereas the carbonate ion is from a weak acid, so it's going to have a strong basic characteristic. This is going to result in anion hydrolysis. Let me write that a bit better. My handwriting sucks. Anion hydrolysis. Gotta work on my handwriting. Anion hydrolysis, and in this case, the anion is gonna act weak base. Strong base, and it's gonna lead to a high pH, much higher pH than these guys do. So C is the correct answer. Which statement is correct for the reaction below? So we have manganese MnO4 minus, and we have a reactor with all this stuff to form the rest of this stuff. If we look here, the overall charge of this molecule is -1, and each oxygen is -2 to form a total of -8. So the manganese must be +7, and we have manganese +2, so we have the charge being reduced. So manganese, whatever MnO4 is going to be the substance reduced, and so it's going to be the oxidizing agent, because the oxidizing agent, you may recall, is the substance that's reduced. So this question is going to be incorrect, and this question, sorry, sorry, this answer is going to be incorrect, and this answer is also going to be incorrect. Because if one thing acts as the oxidizing agent, the other must be the reducing agent. Therefore, we can also see that the oxidation number of Mn decreases from +7 to 2 plus, or +2. This is just the ionic form to 2 plus. So B seems to be the correct answer for this question. A voltaic cell is constructed from zinc and copper half cells. Zinc is more reactive than copper, which statement is correct when the cell produces electricity. So for this cell to produce electricity, we've got to have one thing being oxidized and one thing being reduced. And for this to happen, we're going to have the weaker oxidizing agent, so the weaker metal to be reduced and the stronger metal to be oxidized. So since zinc is more reactive than copper, this is going to be stronger and it's going to be oxidized, and this is going to be reduced because copper is weaker. Copper generally has a high tendency to be reduced. So electrons flow from the copper half cell to the zinc half cell. That's not true because it's going to go in this direction. Always from the anode where oxidation happens to the cathode where reduction happens. So it's not going to be this one. Concentration of copper 2 plus increases. Well, let's see. We're going to have reduction occurring here. So we're going to have all these negative charged electrons that are going to be there, and the copper 2 plus ions can combine with 2 electrons to form solid copper. So this actually would decrease. Electrons flow through the salt bridge. That's plain not true. The salt bridge has ions that move to neutralize changes in charge. So since the copper 2 plus ion concentration is going to decrease, we're going to have the cat ions move here to make this more positive to counteract the decrease of positive charges. And here, since we have zinc 2 plus being formed a lot, because you have zinc being oxidized like that, then the movement of anions is going to neutralize this super positive charge with some negative charges. So it keeps the thing balanced. So negative ions flow through the salt bridge from the copper half cell to the zinc half cell. That's true because we explained how the salt bridge has negative ions, or anions move towards the zinc half cell from the copper half cell. So D is correct. Which signs for both delta for cell potential and delta G of Gibbs free energy result in a spontaneous redox reaction occurring under standard conditions? Whenever we talk about spontaneity and something being spontaneous, delta G is negative. You got to remember that. So options A and B are going to be completely eliminated. And for the delta G formula, we have delta G equals RT Ln K, and I just realized that's the wrong formula. It's NFE, NFE, maybe it's F, no, it's capital F, I believe, Faraday, something like that. Don't really know this topic that well, but it looks to me that N and F are always positive, so for this whole thing to be negative, as delta G has to be negative for something to be spontaneous, E would also have to be negative, so I'm going to guess C is the correct answer for this question. An iron rod is electroplated with silver, which is correct for the condition of this process. The silver electrode is the positive electrode. Well, in electrolysis, the positive electrode is the anode, and that's where oxidation happens. And if oxidation happens there, that means we have Ag silver plus ions being formed, and those will electroplate onto the iron rod. So that seems to be the correct answer. I'd go with A. The structure of a drug used to treat symptoms of Alzheimer's disease is shown below. Which functional groups are present in the molecule? So here we do have the hydroxyl group right here, and ester group, yes, we do have it here. So this seems, no, we don't have an ester group. This is an ether group, I believe. Esters and ethers are really confusing, and I actually don't know the difference myself. But I feel like this is not an ester because we don't have a we don't have a OH group nearby. Like OH is all the way here, so I'm gonna guess that this is not an ester. So we can get rid of those. And the hydroxide functional group, hydroxide is not a functional group, so this is eliminated. And I accidentally eliminated this option, but C seems to be the correct one. Hydroxide is not a functional group. A this is a polyatomic ion. Which monomer is used to form the polymer with the following repeating unit? So it looks to me like there's one, two, three, four. There seems to be a double bond between um, this thing and this thing that's going to be breaking. So it looks like it's a double bond like that. This answer seems to be correct because one, for starters, it's symmetrical. This one's incorrect because it has no double bond. This one is completely impossible. These ones are all impossible. So A is going to be my answer, which is correct for the conversion of propanol to propyl methanoate. We have propanol going to, so propanol sorry, is an aldehyde, and for an aldehyde to um, form a propyl methanoid, that's going to be an ester, and an ester involves a carboxylic acid and an alcohol. And I know that aldehydes can be oxidized to form carboxylic acids. So this must be well, it's not. Okay, now it's really awkward. This seems to be an alcohol only. Okay, so this seems to be an alcohol. So for this alcohol to form, then that means the aldehyde must be reduced. Okay, so they're going the alcohol approach, not the carboxylic acid. So alcohols, I believe primary alcohols are oxidized to form aldehydes. So when aldehydes are reduced, the opposite of oxidation, you can go back to the alcohol. So the reagent for step one would be something like sodium borohydride, because one thing that they can do is they can produce it. They have the hydride ion, which is a strong reducing agent. So it's going to be either C or D. And these ones, this cannot be right. And water, you can't reduce something like an aldehyde with water. Now, reaction step two, you have concentrated hydrochloric acid and methanoic acid. Here, I'm tempted to go with option D because it says it's a condensation reaction, which it is true because when you have a carboxylic acid and an alcohol coming together to form an ester, it is basically a fixing together reaction or a condensation reaction. So I would go with option D. Which statement is correct for the pair of enantiomers under the same condition? So enantiomers are going to be opposite or mirror images of each other at every single chiral center. Um, a racemic mixture is never optically active because the plus and minus enantiomers cancel out. They have the same chemical properties in all reactions. That's not true. They have the same melting and boiling points. That should be true. They rotate plane polarized light by different angles. That should also that no no that's not true. It's just different directions. The angles are the same. So I think C would be the correct answer. A student carried out a titration to determine the concentration of an acid and found that his value had good precision but poor accuracy. Which process explains this outcome? Consistently overshooting the volume of solution from the burette into the flask. Consistently overshooting does seem to be like something that would give poor accuracy, but if it's consistently done, it would give good precision because precision is to do with how close the values are, whereas to each other, whereas accuracy is how close they are to reality. So here we would have something that's far from reality because we're overshooting, but since we're doing it consistently, we're going to have high precision. So A seems to be the correct answer. What is always correct about the molecular ion in the mass spectrum of a compound? M plus is going to have the smallest MZ ratio. No, I don't think so. It's going to have the highest because it's a molecular ion. The MZ ratio gives the relative molar mass. That seems to be correct because when we learn about mass spectroscopy, well, mass spectrum, sorry, the first thing we learn is to determine the molecular mass of the compound by using the parent molecular ion. Which property explains why tetramethylsilane can be used as a reference standard in HNMR spectroscopy? High boiling point, that's irrelevant. Reactive compound, that's irrelevant. All its proteins are from the same chemical environment. That would mean it has a single peak, and it never gives multiple signals. C is the correct answer. Now it's time to check what we got. So after looking at the answers, it seems that we got 38 out of 40, which is a really high score in paper 1. The questions we got wrong were questions 23 and questions 32. So let's have a look at them again. So I got question 23 wrong here. So the E value is apparently the slope of the lnk versus 1mt does not equal EA. It's actually going to be the EA we calculate from multiplying m by the ideal gas constant and making it negative. So it doesn't actually directly equal to EA. So number 3 was incorrect. So the correct answer was 1 and 2A. So it's a bit confusing, this stuff, and I actually did my chemistry IA on this stuff, so I do know how to get around it. So if you guys do find this concept of working out the activation energy from an Arrhenius plot and using the Arrhenius equation quite difficult, then please do say so in the comments down below, and I'll be sure to make a video on it very soon for you guys' benefit. Now let's move on to question 32. Okay, so for question 32, this was a very silly mistake. The formula itself was delta G equals negative NFE. So for this whole thing to be negative, then given that these two are always positive, this E value would have to be positive. So D was the correct answer. So here, since I didn't have the data booklet, I didn't really have the formula memorized well enough, and I was a bit rushed. But hey, it's a simple mistake, and we only made 2 whole mistakes in the entire 40-question past paper. So other than that, guys, I hope you enjoyed this video and you were able to successfully improve your revision for your IB chemistry paper. If you guys did find this helpful, I would really appreciate if you guys like, comment down below, and also subscribe if that is possible. It really helps out the channel and it's highly appreciated by me. Also, with the comments, please comment down below any topics you guys want me to cover. I'd be really happy to help you guys out by making videos on these topics. Other than that, guys, see you in a future video. Peace out.